Okay, so we'll take our quick look at the calendar. Happy Friday. I don't have your tests or your quests for you today. I'll have them for you on Monday. So today we're moving on and we're doing a new topic called solving quadratic equations by rooting and factoring. So this whole factoring business that we've spent the last couple of classes on, essentially today is why we spent that time factoring, is to give us the ability to solve some more complicated equations. So that's the plan for today. We just had our quest, so there's not going to be another one until a while. Looks like end of April, April 27 is going to be our next assessment in class. That's quest number 4, followed pretty quickly by test number 2. Any questions on the calendar? Okay, so starting at the top of 141, Jeremy. Okay, so 2 techniques to solve the same kinds of equations. Lucas, number 1.
To solve the equation x squared equals 16, we need a way to put the square the opposite square root, so the square root of both sides.
Okay, so we started with x squared equals 16. By the way, all the equations we solved today are going to have a squared in them. That's what the word quadratic means. It means the equation has an x squared in it. And so every one of our equations will have an x squared. And in this case, the goal is to solve for x. And we know that taking the square root of both sides is an okay thing to do, right? As long as you do it to both sides, you're fine. So we take the square root of both sides. And notice that I've gone out of my way to write a whole extra step, right? I just copied the x squared equals 16, and then I put that square root symbol on top. I think that's a good idea to just add that step. And then square root of x squared just becomes plain x. That's why we did the square root. And then the square root of 16 is 4, yes? So x equals 4 is the answer, and we buy it, right? X equals 4 works when you plug it in over there, because 4 squared equals 16, yeah? Is 4 the only solution to that equation? Ben says negative 4 is a solution. Lucas agrees. If you take negative 4 and you square it, you still get positive 16. So something went wrong because we found only x equals 4 and we lost the other solution, yeah? Okay, so here's the problem. The problem is that I said that, oops, not there. I said that the square root of x squared is the same as x. And that's not true. You guys remember this was a detail, but the square root of x squared is not just plain x. Remember what it is? It's the absolute value of x. Do you guys remember that whole even odd thing? This is a square root, so that square, that 2 even means that the absolute value gets its revenge. So it really should have said, instead of x equals 4, it should have said absolute value of x equals 4. And that's what I've got here. So this is what we should have had instead of this. And when I say, hey, I'm thinking of a number, and when I take the absolute value of that number, I get 4, then what are the numbers I might have been thinking of? Plus or minus 4, right? Do you guys agree that looking at that red circled equation, the 2 solutions to that equation are clearly 4 and negative 4, right? Because those are the numbers that have absolute value equal to 4. So that's the trick, is that you got to make sure you remember the absolute value, and then that's where the plus or minus comes in, okay? All right, let's move on to number 4, and we'll go to Marcy.
Taking the square root of both sides is a good technique. 7x squared minus 1. I eventually take the square root of both sides. That technique would work on x squared. The x term, taking the square root of both sides.
Good. Okay, so take a look at the first equation. It's underlined in blue here. It has lots of x squared terms, but it has no single x term. Agree? Whereas this guy over here, underlined in black, it has an x squared term, great, but it also has an x term, that 25x, yeah? And there's a big difference between solving these 2 equations. We're going to solve this blue one by eventually taking the square root of both sides. It's actually written out here in number 5. So we'll look at that in just a second. But if you try taking the square root of both sides over on this equation, okay, so the square root of x squared, that's going to be the absolute value of x. That's fine. But then I still have an x under a square root, and having x under a square root is a bad place to have x. The goal is to make the x available, accessible to us. And if you just take an x that's free, like that 25x, and you bury it inside of a square root, you are not making us any closer to the solution. So we see why taking the square root of both sides of that equation is bad. So big difference between equations that just have x squareds, like this underlined blue one, and then the more normal equations which have both x squareds and x's, which will require a new technique. We'll see it at the bottom. Okay, so number 5 says the first thing to do is isolate the x squared. So I see x squareds on both sides. How do I get them together? What can I do to both sides to bring all the x squareds to the left? Subtract the 3x squared. So how many x squareds will we have? 4x squared. And then we're going to move everything else away from the x squared. So we're going to move this -1 over to the other side. This is all part of isolating the x squared. So I get the x squared on the left, everything else on the right. So I think we agree with that one, right? We said we'd have 4x squared, and then we're going to add the 1 to both sides. So that's going to give us 200. So now we're here. We still haven't isolated the x squared yet. What do I do to both sides to get the x squared by itself? Divide by the 4, right? So we divide both sides by 4 and eventually get to here, x squared equals 50. Okay, finally the x squared has been isolated. What do we do to both sides once the x squared has been isolated? Is we take the square root, right? So this is that moment where we take the square root of both sides. Notice that I've written it out just as a completely separate step. And then the last little twist here, that looks like it's just x, but it's not just x. What is it? It's absolute value of x, right? Square root of x squared is not plain x. It's absolute value of x. It's there. Square root of 50, you guys did some stuff like this on your quest, simplifying that kind of thing. So I trust that with a little bit of time, we could simplify that to 5 radical 2. And then finally, if the absolute value of x is equal to 5 radical 2, then x is either 5 radical 2 or negative 5 radical 2. Whenever we have this absolute value business, it's just a matter of putting the plus or minus in the front. So our solutions are over here, plus or minus 5 root 2. Right, I don't want to say absolute value of x equals 5 root 2 because the goal is to get x by itself. And it's still buried if you leave the absolute value there. Good question. Okay, let's go to Cody for 6. Okay, good. Kayla, 7. Go ahead. Okay, so let's start there. You can use mine. Okay, so as Cody read, having 0 on one side apparently is useful. We'll see why in just a second. So we're going to move that 5x over to the other side by subtracting 5x from both sides. And we're also going to put the terms in descending order of the power as Kayla read. So the x squared will be our first term, the x term will be the second, and then the constant, the number without any x's, will be the last term, and then equals 0. So that's right. Subtract the 5x and just put it in the middle so that things are in order. So x squared minus 5x minus 24 equals 0 is our equation. Okay. All right. So the rest of the solution is written out below. We're just going to run through it quick, and then you'll do lots of practice with it. So it's okay if you don't get all the details here. We're going to factor this thing on the left-hand side. First of all, how come taking the square root of both sides is not the appropriate technique for this one? There's an x squared. Say again? Can we find the square root of 0? It is 0, yeah. So square root of 0 is okay, but it's close to numbers that are bad, like square root of -1 is bad. So square root of 0 is okay, but there's something more fundamental here that says taking the square roots is not the right technique on this one. Is the x by itself. That's it, right? The square root technique is good if there's only x squared terms, but no x by itself term, and that minus 5x is the problem. Okay, so that's why that technique is no good. So the other technique, we said we're going to factor. So this thing on the left-hand side factors. Ignore the equals 0, just x squared minus 5x minus 24. You can factor it using a box or some other technique. Some of you guys are really good at factoring stuff like that quite quickly. Like I said, I'll never force you to use a box. I just need you to be able to factor it. So that equation right there, when you factor it, becomes this guy right here. So we're not going to do the box, but you can verify it later on. But you make the box and it turns into this guy. Okay, so now we have the whole heart of why we put a 0 over there on the right-hand side. At the moment, here I'm going to highlight two different things here. I've got this yellow thing and I've got this green thing, and they are being multiplied together, yes? Okay, if you multiply two numbers together, which is what we're doing, and you get 0, what can you tell me is definitely true? That x is 0? I've got two numbers multiplied together and I get 0 as the answer. One of the numbers has to be 0. Agree? If you multiply two numbers together and you get 0, definitely one of those numbers had to be 0. It's the only way to get 0 when you multiply. So what we're going to do is assume that either the yellow thing is 0 or the green thing is 0. One of them has to be. But if we had left it, don't copy this down, but suppose that we had left the, let's put a 24 over here. Just pretend we had put a 24, not 0, any other number besides 0. Now I'm multiplying two numbers and I'm getting 24. Does one of the numbers have to be 24? What could the two numbers be to get 24? Could be 6 times 4. Could be 8 times 3. Could be 12 times 2, right? Could be 7 times 24 sevenths. Because you multiply two numbers and get 24, you don't get any information, right? The two numbers could be anything. There's something really special about the number 0. It's the only number with this property that if you multiply two numbers and get 0, one of them has to be 0. That's why 0 is so crucial over there. You buy that? Okay, so we said either yellow is 0 or green is 0, and so we take an extra step and we just write down, okay, yellow is 0 or green is 0. And then we solve those two simpler equations. They're both a lot simpler than the original equation we started with. So in the yellow equation, we'll solve for x by adding 8. We get x equals 8. Green equation, we subtract 3 from both sides. We get x equals -3. All right, so some of you smarty pantses are going to say, oh, wait a second. If it's a -8 there, then it's just a +8. And if it's +3 there, then it's just a -3. I would encourage you not to treat this as a shortcut. It's true in the simplest cases, like this one. But we're going to run into issues where if you just memorize this shortcut and you don't really understand what we're doing, you're not going to know how to handle it when things get a little bit tougher than they are here. So I recommend not memorizing this sort of opposite sign shortcut. Just write the two equations, yellow and green, solve them separately and get your answers. Okay, so two techniques from today, solving by eventually square rooting and then solving by factoring. These are really, really important techniques to us. Activities start on the next page. Let's see how far we can get.